So when something is concurrent, it's when three or more lines intersect at the same point. The point of concurrency is the point where they intersect. So where all three lines do intersect, that's what we would call it, is the point of concurrency. The circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. So remember, concurrency means, or the point of concurrency is the point where they intersect, and it's when there's three or more lines. So when we have a triangle and we have our three perpendicular bisectors, that's when we have the circumcenter. So the point where these three lines intersect is called the circumcenter. So the incenter is the point of concurrency of the angle bisectors of a triangle. So it's the So again, just like with the other one, my three perpendicular bisectors, they meet at the point that's called the circumcenter. When I have my triangle and my angle bisector, so if I have my three angle bisectors, they all meet at one point, which is called the incenter. So the median, it's a segment whose endpoints are a vertex and the midpoint of the opposite side. So here when we look for a median, if it starts at a vertex and it goes to a midpoint, then it's our median. A centroid is the point of concurrency of the medians. So if I have a triangle and I draw in my three medians, where they all intersect would be at the centroid. So altitude is the perpendicular segment from a vertex to the line containing the opposite side. So here we're looking for it to start at a vertex and it creates a perpendicular segment to the opposite side. So the orthocenter is the point of concurrency of the altitudes. So when I have my triangle and I draw on those three altitudes meet at the orthocenter. So looking at example 1, we're going to be using medians and we want to find the length of AB. So we're trying to find this distance right here. given that BD is a median. So a median is a segment whose endpoints are a vertex. So BD, it starts at a vertex and the midpoint of the opposite side. So when it comes down, it makes a midpoint. So that means where this meets, these are now cut in half because it's at the midpoint. So vertex down to our midpoint, cut in half. And it says that the length of BC right here is 20. So since this is the median, I know that's my midpoint. AB is also 20. Example 2, we want to identify the center represented by P in each figure. So we first want to identify what types of lines we are using here. So if I look, I am creating 90-degree angles. So that would be means it's perpendicular. And also where they meet, it's dividing these in half, which means this is the midpoint. So if I'm dealing with something that's perpendicular and it's the midpoint or it's being bisected, I'm dealing with perpendicular bisectors because they create a 90 degrees. Bisector means that you're splitting something in half, so it's the midpoint. So I have perpendicular bisectors. So that means this point right here that we're trying to identify where those three meet at the circumcenter. Let's look at the next one. They are starting all at a vertex and they end up at a midpoint. So if I'm going from a vertex down to a midpoint, because it's cutting these in half, vertex and midpoint, that means I'm dealing with medians. So all three of these lines are medians. And I know medians all meet at the point that's called the centroid. So the next one. Again, they're starting at a vertex and they create a 90-degree angle, so that means they're perpendicular. So I'm at a vertex and I create a perpendicular segment, so that means all of mine are called altitudes. And the point of concurrency where those three lines intersect, if they're all altitudes, that means it's the orthocenter. And the last one. Here, yes, they start at the vertex. However, though, the line right here is cutting and splitting my angle in half, so that means it's an angle bisector. So when I'm talking about angle bisectors, write that part down. The point of concurrency of angle bisectors is called the incenter. Sorry, I didn't see the last incenter. Okay, example 3. We are being told that P is the centroid. So just to remind us what a centroid is, remember the centroid is the point of concurrency of the medians. A median is where we start at the vertex and we go to a midpoint. So they all start at vertex, they all create in this midpoint on each of the opposite sides. So if P is the centroid, I know that the distance from P to A right here is 4. I also know PE is 7 and BP is 10. I want to find the lengths of AD, CE, and PF. So if I'm wanting to find the length of AD, so this is my missing one, I'm going to mark that. Oop, 80, sorry. AD, the whole distance from here to here. So what I have is I know a part of that, which is AP, is 4. And I know I'm trying to find my whole length. My whole length is AD. Well, if I take a look at this, my 4, this is actually the longer segment. PD is the shorter. So that means 4 is 2/3 of whatever my whole length is. So if I take the whole length and multiply by 2/3, I end up getting a 4. So what I'm going to do to both sides to solve this is I'm going to multiply by the reciprocal, 3/2. So 4 times 3/2, I get 6. So the length from A to D is 6. So 4, this is 6, so that means this distance right here would be a 2. Alright, so for the next one, I want to find the length of CE. So CE is this whole median. So again, I'm already given a 7. My whole length is CE. But when I look at this time, this part's the longer segment, this one's the shorter. So that means 7 is actually 1/3 of the whole length. So again, in order to solve this, I'm going to multiply by the reciprocal. So 21 is my whole length, which is CE. Okay, last one, we're trying to find the distance of PF. So PF is actually just this little chunk right here. So what I'm going to do first is I want to find what the whole distance is. So if I take my 10 and I take the whole distance, which is BF, 10 is actually the larger segment, so it's my 2/3 of my whole segment. So I am going to multiply both sides by the reciprocal, which is 3/2. So 10 times 3/2 is 15. And that equals the whole length. I'm not trying to find the whole length. I want to know F to P. Well, I know that from B to P it's 10. So if I just subtract 10 from 15, I know my length of FP is now 5. Alright, example 4, we want to identify our lines. So the first one we want to identify is our median. So remember, our median deals with a vertex and it goes to a midpoint on its opposite side. So if I'm taking a look, here it starts at a vertex, but it doesn't identify that it's the midpoint. That one starts at a vertex, but that doesn't identify it's a midpoint. Here, I start at a vertex, and I go to a midpoint, because I know those two are congruent. So my median is RT. Next, I am looking at an altitude. An altitude starts at a vertex, and it creates a perpendicular segment. So if I'm looking for something that creates a perpendicular, here it starts at the vertex, then it creates my perpendicular line, so that means QV is my altitude. So then lastly, I'm looking to identify my angle bisector. Well, this line right here is splitting this angle and cutting that in half, so that means the line of US is my angle bisector.